Hello and welcome. The topic of our discussion is haloalkanes and its classification. Haloalkane consists of alkane and halogen. Alkane consists of hydrocarbon, which is carbon and hydrogen atom only. There is a single bond between carbon atoms. For nomenclature, there is an ane ending. Here is an example. There are 2 carbons and 6 hydrogens. There are no other atoms in the molecule. There is a single bond between carbon and carbon. And for the ending, it's ane. So let's talk about this name for a moment. Ethane. There are 2 carbons. An, there is a single bond between those 2 carbons. E specifies hydrocarbon functional group. Halogen. Those are nonmetals in group 17 or 7 in the periodic table. The 5 main elements in this group are fluorine, chlorine, bromine, iodine, and astatine. Usually, for halogens are most often used in organic chemistry. Since those atoms are located in the same group, they typically would have a similar chemical properties. Haloalkanes are also called alkyl halides. Those names are interchangeable. Haloalkanes are compounds in which hydrogen atom of an alkane is replaced with halogen atom. And like we said before, there are 4 common halogens are used. The general formula for haloalkane is R, a single bond X, where R is any carbon chain and X is halogen atom. Here is an example. So you can see on the left that this is ethane. It has 2 carbons connected by a single bond, and there is a hydrogen. If you take a look on the molecule on the right, the hydrogen is being replaced by chlorine, and you can also feel free to add 3 lone pairs or 6 electrons surrounding chlorine. Classification. Alkyl halides are classified as primary, secondary, or tertiary, and it's based on a carbon to which halogen atom is directly attached. Primary carbon atom or primary alkyl halide. If you take a look on this molecule to the right, we have chlorine is attached to this carbon, and this carbon is selected to 1 carbon. This is why it's a primary alkyl halide. Secondary carbon atom and secondary alkyl halide. In this molecule, the chlorine is connected to the carbon, and this carbon is connected to 2 other carbons, one on the left, one on the right. This is why this is the secondary alkyl halide. Finally, tertiary carbon atom and tertiary alkyl halide. If you take a look on this molecule, the chlorine is connected to the carbon, and this carbon is connected to 3 other carbons. This is why this is the tertiary alkyl halide. Constitutional isomers. Isomers have the same molecular formula. They have different connectivity or bonding arrangement. They might have different physical properties such as melting or boiling point or density. And they might have different chemical properties such as reactivity. Here is an example. The molecule on the left and molecule on the right, they have same number of atoms. If you take a look, the one on the left, it has 1, 2, 3, 4, so there are 4 carbons. And 3, 6, 7, 10 hydrogens. The molecule on the right, 4 carbons, 5, 7, 10 hydrogens. They also have different names. If you take a look on this molecule, so first of all, the longest chain is 3, no matter which way we are counting it. From left, from right, or from the top, it's always going to be 3 carbons. And on the third carbon, there is a methyl group. So if you take a cross, this is the methyl group, which is the alkyl or attached substituent. If you take a look from up to left or right, this is the same, but there would be still methyl group on left or right side of the molecule. 2-methylpropane. This is the name of this molecule because, first of all, 3 carbons across. AN, all single bonds. E means hydrocarbon, which is hydrogen and carbon only. And on the second carbon, there is a methyl group. This is a butane. But means 4 carbons. AN means all single bonds. And E means hydrocarbon. Here is the problem. Write all the structural formulas for C4, H9, Cl and classify each as primary, secondary, tertiary alkyl chloride. What I would suggest to start this question is to start with longest chain and then work your way down to the shortest chain possible. So first of all, we are going to try to do 4 carbons in the longest chain. So let's do a little bit of sketch. 1, 2, 3, 4. How now? So we got four carbons, and now we need to use 1 chlorine. You can put chlorine in any position. I typically start from left to right. So for example, you can put it on this one here. Now, everything else is going to be hydrogens. Keep in mind that carbons should always have 4 bonds to make it stable. So this carbon has 2, 3, 4. So this is where the hydrogens would be. So 1 hydrogen, 2 hydrogen. This one has 2 bonds are here. So third one and fourth one would be hydrogen. Hydrogen, another hydrogen, and 1 bond attached to this carbon. So there would be 3 other hydrogens. So there is total of 4 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9 hydrogen and 1 Cl. To name this molecule would be, first of all, you know it's a 4 carbon chain, but, all single bonds, An, hydrocarbons, E, so it's butane. Now chlorine is attached to the first carbon, so that's why it's 1-chlorobutane. Now we can come up with a similar structure for 4 carbon chain, but instead of having Cl on the first carbon, we can attach it to the second carbon. Now this is exactly the same molecule as before. The only difference is chlorine is in different position. The chlorine is in different position, and molecule, if you do the count, you got 4 carbons, 1 Cl, and 1, 2, 3, 4, 5, 6, 7, 8, 9, and there are 9 hydrogens. So this molecule is still valid. The name would be different. This time it would be 2-chloro. Chloro is attached to the second carbon, butane. Next. And here we can see the actual structures. So on this molecule, we got 4 carbons in as a longest chain. Chlorine is attached to the first carbon. Now, this carbon is attached to one other chlorine. This is why this is the primary alkyl halide. The second one is very similar to the first one. The only difference is we put chlorine in a secondary position. So that's why it's 2-chlorobutane, and this carbon which bears chlorine is attached to two other carbons. This is why this is the secondary alkyl halide, or secondary chloride, alkyl chloride. Now we are done. So for example, if you would put chlorine into the third position, so for example, if you do something like that, let's say you put chlorine in this position, now this conformation would exactly resemble previous conformation, because you would have to just start counting not from right to left, from left to right, but from right to left, and chlorine would end up in a secondary position, which exactly means this molecule. Same goes if you put this chlorine on the first position, then you would end up exactly the same conformation as on the left. Now, for 4-carbon longest chain, there is nothing else we can do. That's why we are going to attempt to do 3-carbon chain. There are 3 carbons. Now, we are missing just one single carbon, and you cannot put it on the first or on the last because it would give us 4-carbon chain. That's why 4th carbon we are going to put to the center carbon, like so. Now there are 4 total carbons. Now the question is where to put chlorine. Even though we have 4 carbons available where chlorine can go, but in reality there are just 2 main places where this chlorine could go. First of all, you could put chlorine on any of those 3 carbons. And all of those 3 carbons are the same because they all attach to the center carbon. So for example, if you would put it on this carbon or this carbon or that carbon, they all would have identical structures and identical name, because this chlorine carbon where chlorine is attached would always be carbon 1. So this is one possibility. And the second possibility, if you attach chlorine to the central element over here. Now let's take a look at actual structures. So now we got 4 carbons. So there is still 4 carbons. There are 3 carbons in a longer chain. And we have substituent we got this carbon over here, and this carbon connects Cl. This carbon has Cl group. Now, it doesn't matter whether you would put this chlorine on this carbon or that carbon, they would all give us identical structures. And when you do the parent chain or the longest chain, you would have, for example, those 3 carbons being part of a longest chain. This is the primary carbon, because this carbon bearing, this chlorine is connected to this carbon, and this carbon is connected to only one carbon. Hydrogen does not count. So this is the primary alkyl chloride. Finally, we have same structure as before. We got 3 carbons in the longest chain. You could go straight, you could go to the side. It doesn't matter. Chlorine is being attached to the central carbon. Now this is the tertiary carbon. This is the tertiary alkyl chloride. The reason being is because this carbon is attached to 3 other carbons. So all those structures have the same formula, C4H9Cl. Please let me know if you have any questions in the comments below, and I'll see you in the next tutorial. Thanks for watching.